Hello, and welcome to our Dlubal tutorial. In this last video of our online course, we will learn how to model a parametric membrane structure in Rhino and Grasshopper and export the results to RFEM 6. First, we create a point using the construct point component from the Vector tab. After that, we copy this component twice by holding down the Alt key and dragging. For the second, we set up a range for the x-coordinate, for example, from 1 to 20. Then, we enter width for this slider name. We would like to set the third point in the middle of these 2 points, but with variable height. The x value has to be the x value of the second point divided by 2. To do this, we insert the division component. Now, we connect A to the number slider. For B, we enter 2, using the number slider command. Afterwards, we set up a new range for the z-coordinate, for example, from 1 to 15. After that, we enter height for this slider name. In the next step, we create a curve from these points using the interpolate component. After that, we plug the 3 points into this component. Make sure you put them in the right order, as shown here. Next, we copy this curve as well as the points in the y direction using the move component. We also insert the unit vector parallel to the y-axis component. Now we set up a new range, for example, from 1 to 30. Then we enter length for this slider name. Afterwards, we create lines between the corresponding points using the line component. After that, we create a surface through these 2 curves using the loft component. Then, we connect these curves to the curves in the loft component. In the next step, we mirror all these components using the mirror component. You can find it in the Transform tab. As shown here, the mirror plane is YZ by default. We have to change it to XZ using the XZ plane component, which is in the Vector tab. Next, we copy all the objects using the appropriate command from the Params tab, as you can see. Then we make groups, enter names, and change the colors. Next, we put all the number slider commands together in a group to control all the parameters easily. Then, we enter parameters for this group name. Now we assign members to these lines using the member component. We select the beam type using the value list command. Then we connect all the lines to the grasshopper line in the member component. After that, we define cross-sections using the section component. We enter 1 for the cross-section number. And CHS 193.7 times 5 for the section name. Afterwards, we define the material using the material component. Now, we enter 1 for the material number. And S235 for the material name. Next, we transfer these model data to RFEM6 using the Dlubal component, RFEM6 export component. To start the export, we use the Boolean toggle command. We also overwrite the previous data in RFEM by using the Boolean toggle command and switching it to true. To perform the export, we double-click the Boolean toggle command. For cables, we assign another cross-section. Therefore, we copy both the member and section components. Now we have to change the cross-section number to 2. The cross-section name to R20. And the member type to cable. To create a surface for RFEM, we insert the Dlubal component titled Surface. First, we connect the surface to the grasshopper surface in the component. Then we enter numbers 1 and 2 for the surface number. To define the stiffness type, we insert the value list command, then select Type Membrane. To enter the thickness number, we insert the thickness component. For this component, we have to enter the thickness number. For this, we enter number 1. We also have to enter the thickness value using the number slider command. To define the material number, we insert the material component. For this, we enter 2 for the material number and ETFE for the material name. Then we connect these components to each other. Finally, we assign rigid supports using the nodal support component. First, we have to connect the nodes to the grasshopper node in the component. After that, we enter the support conditions using the panel command. Then, we connect this panel to the support conditions in the nodal support component. Thank you for watching. If you have any questions, you can write them in the comment section below. If you like this video, don't forget to like and subscribe. You can also visit our website at dlubal.com and search for anything you need. Goodbye until our next tutorial series.